Hi class! How are you today? That's great. The learning target for today is to transform figures using dilations. So, I know it's been a while since we've done transformations, but now we're going to use another form of transformations. The difference is the three we learned before, translations, reflections, and rotations, were all rigid motions. Doesn't change the size or shape. Dilations change the size of the figure. So, for a scale 3, you can transform figures using dilations. 2, you can dilate, which is to transform figures using dilations. You can dilate figures if they are on a graph, so like a coordinate grid. 1, you can tell what type of dilation it is, but you cannot dilate the figure yourself. And 0, you cannot determine the type of dilation. Let's get started.
All right, so the first example is we want to dilate this figure, this triangle here, from a center of dilation C. So the center of dilation is right here. It's C. And a scale factor of 1/2. So first thing you want to do is you want to draw dotted lines from the center to each vertex, each corner of the shape. So you take a ruler and draw a dotted line from each center to the vertex. All right, so we have our 3 dotted lines. Now we look at the scale factor of r equals 1/2. What that means is we are going to dilate this figure, but we're going to make it 1/2 the distance of each of these lines. So each of these vertices are going to become halfway through these dotted lines. So what you do is you take your ruler and this line happens to be 9 inches, so we would find 4.5 inches, which is halfway, so you want to find halfway, and you make a point. Find halfway on this one. Again, that one's 9 inches, so 4.5 as well. This one is a little over 13 inches, about 13 inches and 2/16, so half of that, so half of 13 is 6.5, and then one more 16th after that. So it should be right about here. And if you don't have a ruler, you can use some sort of straight edge that allows you to figure out what would halfway be, something that you can mark what's halfway, that sort of thing. So, now we want to finish the shape, so we connect them. Probably best to use a ruler if you want, but to save time I won't. But you do want to use the ruler when making your dotted line and your measurements. So, we just dilated this figure by 1/2. So it's now half the size, but it's also half the distance to C. So those are the two things a dilation does. It makes it smaller, but also makes it half the distance between the two with the scale factor of 1/2. All right, one last thing about this example is if the scale factor is between 0 and 1, so if 0 is less than r is less than 1, so if it's between 0 and 1, the dilation is going to be what's called a reduction. It makes it smaller. So if it's anywhere between 0 and 1, it's a reduction. Alright, so now in this problem, same sort of problem, dilate the figure from center of dilation and scale factor, but this time the scale factor is 2. So, same first step, we want to make a dotted line from each of the vertices to C. Alright, so same step as last time, we made our 4 dotted lines. Now, it's a scale factor of 2. So we have to figure out twice the length of each of these dotted lines. So we want to extend them out twice as far as they do here. So, measure each vertex. And this one's about 7 3/4. So then from here, we go another 7 3/4. You want to make sure that your ruler will continue to go in the same direction. So here's point from the first vertex, and then we do that for the same, for all the rest. So this one here is about 13 and a half. So we want to go another 13 and a half. If you want, you can also just keep your ruler and say 13 and a half times 2 is 27. So that means we want to go up here. So we continue our dotted line all the way up. And we have our point right there. Next, we continue this one. Again, that one's 13 and a half, so 27 will be right there. And this one is about 8, so that'll put it at 16. So right there. So we have our 4 vertices, and so we make it into our rectangle. And there we go. We just took this figure and doubled its size. But again, we also doubled its length from center C. So it did both things. So for this one, it's called an enlargement. So if R is ever greater than 1, it's an enlargement. It makes it bigger. The next one, we have dilate the figure from center of dilation C and scale factor R equals 1. So in this case, it would say that we'd want to draw our lines, and then since it's a scale factor of 1, we would then want to draw our new vertices exactly 1 times the distance of each of our lines. Well, 1 times anything is itself. So our lines would stay the same length. And so our lines would show up exactly where they originally were. So all the vertices would stay the same, and our new figure would be the same figure. Nothing would move. So when this happens, this is known as a dilation of congruence. And that's whenever R is equal to 1. All right, here's the final example. Dilate the figure from center of dilation C and scale factor R equals -1/2. So what we're going to do in this problem is first the same thing. We draw our lines. So now that we have the lines, once again we measure how far away they are from each other. So this one's going to be 6 3/4. So half of that would be 3 3/8. So since it says negative, we go in the opposite direction and we do half the length. So not only are we going half, but we're going in the opposite direction. So make sure your line lines up in the same direction. And we want to go 3 3/4, 3/8 right here. So here's our first vertex. Same thing for this one. This one is 6 1/4. So that will become 3 1/8. And then this one right here is about 9 3/4. So that'll become, we'll go 4 1/2 and then another 3/8. So 4 7/8. Have to do it in this direction, so we'll put 4 7/8 on our dot. And so it'll be right there. So we have our 3 vertices. Now we connect them to make our triangle. So in this case, we've still got a smaller triangle. Just now, it's farther away. We went all the way and then another half in the opposite direction. So technically we went 1 1/2. So whenever it says negative, you do what it says, but you go in the opposite direction of it. So now we have to figure out what kind of transformation it is. So those 3 I gave you before, reduction, enlargement, and congruent, stay the same. And you only care about the number, not whether it's negative or not. So if it's between 0 and 1, it's still a reduction. If it's greater than 1, it's still an enlargement. If it equals 1, then it's still congruent. So if it said r equals -1, even though it actually would move this time, it would still be congruent. The figure wouldn't change size. So in this case, we have r equals -1/2. So 1/2 is between 0 and 1. So it's a reduction.
Alright, now time for the sponge. So I want you to dilate each figure from the center of dilation C. So in number 1, here's the center of dilation C. Here's the scale factor. Use both those things to dilate this figure. Same thing for number 2, center C. and scale factor is 1/3. And center C, scale factor is -1. Alright, that's it for this lesson. Once again, please make sure to take notes on the entire lesson. Take a picture of your notes and your sponge that you attempted, submit it all to eBackpack, and have a good night.